I'll be presenting also on behalf of our colleague, Lisa Van Diver from NOAA Restoration Center, who has been working closely with us in the implementation of this project. So Protectores de Cuencas is a nonprofit organization that was founded in 2012. We have been working across our nation in different aspects of watershed planning, management, and also implementation of best management practices. So Culebra, it's 11 square miles island. It's roughly 2,000 residents. It's highly dependent on tourists based on its natural features. And it's been a priority for conservation for the Department of Natural Resources of Puerto Rico and also the Restoration Center from NOAA. Based on the attributes of these natural resources, mainly coral reefs and seagrass areas, a lot of investments and efforts have been conducted in Culebra to reduce the land-based stressors to the marine environment. And we are going to talk about a little bit of how that process has gone. So we started with the creation of an integrated watershed management plan back in 2011. It came out in 2014. This is a plan that captures mostly the problems of sediment runoff and also nutrients runoff to the marine environments. Most of these land-based sources of pollutions come from illegal construction activities and the creation and maintenance of dirt roads. More than 90% of the Culebra roads or access roads are dirt roads. So some of the models conducted during the watershed management planning preparation includes, of course, illicit discharge, problems with septic systems, and problems with infrastructure failures for sewer. And also nutrient loads from different sources, including non-disturbed land to have comparison. So since 2011, we have been implementing projects for reduction of sediment and also nutrients in Culebra with different approaches. Sorry. So for the purpose of conducting a specific work and delimitation of priority areas to work with, we have divided Culebra into close to 30 subwatersheds. And then we have made a process of evaluation and prioritization of those areas. This is an example of some of the dirt road system in the priority areas that we are working with. The different colors is just a matter of the different funding sources. But this is just to give you an idea on the areas that we are currently working and the areas that need to be worked on. Roughly 30 miles of these have been estimated as priority for stabilization. So far we have done half of those miles, and we have funding to complete the rest, mostly with NOAA funding. So based on slope, based on proximity to coral reefs, different subwatersheds were selected, and then that same approach was used to select the dirt roads or dirt road segments that were stabilized. Here are some of those practices implemented. We also have the opportunity to test these practices with the help of Dr. Carlos Ramos from the University of Texas in Austin. We were able to test which of these practices are working better than others so that we identify them and we build them for the future and leave behind whatever are not working that good. And you can see we have check dams. We did the concrete crossbar. They didn't work that good, so we changed them to underneath crossing pipes, which neighbors, of course, like them better. They don't like to ride over the bumps of the concrete. But also having concrete with dirt roads, it helps to erode faster. Sometimes one of the practices implemented is concrete pavement. There's some areas that is just too steep to work, and the marine environment is so close. There's no possibility to build a lot of practices. So concrete pavement in combination with best management practices from reduction of water energy is the best option. Also, another option is to work with the cut slopes of the roads, not just the road, but also the bank of that road produces a lot of sediment that needs to be regraded. In this approach, we also have done several coastal stabilization projects. We have a combination of nature-based activities that benefit local visitors because it gives the opportunity of having public use infrastructure. But that same public use infrastructure is the practice itself. Like, for instance, if we are converting a dead road parking lot to a permeable parking, the parking could stay, and then the parking will function as the filter for the runoff from this sea parking and also from roads, adjacent roads network. And this is an example of Tamarindo Beach. This is the marine protected area of Cayo Luis Peña, which is managed by the Department of Natural Resources. And it also has a co-management board in Culebra that serves as the coordinators of the implementation of the plan for preserving this important area. So here we had a huge problem with vehicular access to the maritime terrestrial zone. And also vehicles had access to the beach itself. So our plan, our approach at the moment, this was back in 2011, was to build a permeable parking system combined of several layers of stones and also sand and geomembranes to prevent the sediment runoff to the sea. This is how the project ended up. Unfortunately, the hurricanes Irma and Maria hit this project very hard, and most of the practices were destroyed. So we got a chance to find additional funding from the Department of Natural Resources, the Coastal Zone Management Program, to be able to fix these issues. And this time we had a little bit more budget, so we wanted to build a project that will be more resilient to climate change. So we had the collaboration for this particular project from Tetra Tech in terms of capturing the design and the ideas that we wanted to build, and that was presented to the management board and the community. This is some of the practices built. We did the permeable parking, but this time we used some geo pavers to hold up the gravel in place and prevent it to going into the marine environment. This project was just completed a few weeks ago, and it's functioning. We are now testing. We're waiting for a couple of rain events to test it and maybe tweak a little bit of the practices. And we have a little bit of extra funding for another proposal that we're going to be expanding this project to the adjacent other parkings. Same approach we did in Zoni Beach in Culebra, where we had a dirt road system and their parking lot that were draining directly to the marine environment, and it was converted into a permeable system. I'm going to use this overview here that you will see in other slides, because this is some sort of the application that we use, and it's called the train approach. Usually there's very small areas to do conservation practices, so we have to figure and engineer practices that will take advantage of that space. So we try to do as much as practices as we can in the available space. That's why you see that train approach from one to the other, and then finally to the permeable parking, so that the permeable parking itself is not just the one practice. Otherwise, it will need a lot of maintenance. This is the after picture of that project. And some of the materials that were used for that permeable system. Same approach was conducted in another marine protected, in another protected area, which is called Punta Soldado. And Tamarindo and Punta Soldado are not just important because of they are protected areas, but they are the area where coral farming is taking place by the Sociedad Ambiente Marino and NOAA, which also needs to lower the impacts of the sediment runoff to the coral farming activities. We also have funding to create some pilot project for stormwater treatment in town of Culebra. So we are currently doing design and identification of the areas to implement this green infrastructure. One of the key factors that were recommended in the watershed management plan was the reduction of nutrients generated by the sewage treatment plant in Culebra. So we have funding for another pilot project to develop a series of filtration wetland system. Locally, the sewage treatment plant has 5 wetlands or 5 cells already constructed. It's not working properly because they are too deep and they don't have plants to treat the excess of nutrients. So we're going to build a floating treatment wetland system, 1 or 2 of these cells to monitor and see the changes. And if we can have good results, nutrient reduction, we will expand these to the other cells. This is part of the analysis that we have been conducting over the past years in terms of nutrient from one cell to the other, and eventually discharge to sea. You could see an increase on chlorophyll A as it moves out, and then that chlorophyll A will convert back to nutrients when it gets back to the sea. This is an example of pollution prevention projects where we conduct trainings to heavy equipment operator on how to stabilize the dirt roads in Culebra. We have also applied technicals for hydroseeding, which has also helped reduce sediment runoff in different areas in Culebra. And I will end with this one. This is a very important project because this is the main access for Culebra, and sea level rise and storms are taking over this road, which is very important for Culebra resident because most of the goods for Culebra comes through this road, and it's the only area where the road could be. We have a steep mountain on one side, and then we have the sea in the bay from the other one. So we are exploring right now with funds from National Fish and Wildlife Foundation to have a nature-based approach. So we are currently doing schematic designs to implement a project in this area. And we are doing the monitoring approach, not just in terms of the land. We are currently going to be installing sediment traps in different areas of the bay and other coral reef important areas in Culebra to monitor the effectiveness of those practices. We are also conducting illicit discharge detection and elimination, so that we are finding sewage outfalls inside the stormwater system. This is another example of projects that we are doing across Puerto Rico with the same, basically the same approach of Culebra. And I cannot live without saying thank you to all of these partners. Without the help of the partners involved in this project, none of this could happen. So thank you.
Thank you, Robert, so much for sharing the different projects that that you and your team are working on to address a lot of these critical issues, and also just having that information on how these are performing. I think it's a big question a lot of people have about nature-based solutions. So thank you for your work. So I think you can stop share. There we go. Okay. So our final speaker is Roberto Metier, and he is with Vida Marina Center for Conservation and Ecological Restoration at the University of Puerto Rico at Aguadilla. And Roberto will be talking about dune and mangrove restoration to increase resilience of coastal communities. So you can take it away.
I mentioned my name is Heriberto Martil, project assistant here in Vida Marina for the Mangrove Restoration Project. We're based in the University of Puerto Rico, and we're the Center for Ecological Conservation and Restoration. We are mainly operated by full-time employees, but are really, in a great sense, assisted by undergraduate research students as well as student workers, and a lot of the work we do is also helped out by community members and a lot of volunteer efforts. These are just pictures of our staff. These two main projects that we're working on in this moment, the Dune Restoration Project and the Mangrove Restoration Project, all take part mainly in the northern coast of Puerto Rico. For the Dune project, the main spots that have been worked on are in the municipalities of Isabela, Dorado, and Loíza, where almost 48% of the dune systems are found. But the project is not limited to these three municipalities. At least 9 municipalities along the northern coast have ongoing dune restoration projects. Then for the mangrove project, it is focused mainly in Isabela, where two of the sites or two of the mangroves that we're working on are present, and another third site in Camuy, and the fourth site being in Aguada. And pictures of these sites will be shown just ahead. So just a quick overview of what the Dune project entails and why it's important. Well, of course, it's a habitat for a very important habitat for different biota. Many different species, some of which are endangered, like sea turtles, make their nests here. So this habitat is really important for them. This is also the main habitat where shorebirds and migratory birds find food once they arrive at our coasts. And of course, different types of vegetation, which is of course very important. So the main reason, you could say, why restoring this ecosystem is important is because of the protection they offer to residents, and how they protect our primary infrastructure from extreme weather. So these are just examples of pictures. This is Camuy, Isabela, and Loíza, of sites where the dune ecosystems were completely deteriorated, and after extreme weather events, just the ocean came rushing in and basically blocked main roads, which in cases of emergency is very dangerous, and also destroyed property, like in this example here. So you can see that when these coastal communities, which in some, if not most cases, are either poor communities or just vulnerable in a general sense, do not have a dune ecosystem like this present, or the ones that they have is deteriorated to the point where it's not functional and it doesn't offer the protection needed. This is the end result, just complete devastation. So causes for this ecosystem degradation, of course, illegal extraction along the years, misuse of these ecosystems in a recreative sense. All these practices, even though they are limited and don't really occur in these magnitudes anymore, they still happen. Another reason is bad use of the landscape. People just crossing over the dunes and creating different points of access that end up creating these types of breach openings that ultimately become the areas that are most vulnerable. And these are the areas where ultimately storm surges and wave events just rush in. And most recently also the hurricane, like Hurricane Maria, all these just sum up and have created and deteriorated these ecosystems to the point where they need to be restored, and that's where we come into play. So these are just some examples of the practices that we have ongoing when it comes to the Dune Restoration projects. One of them being the installation of boardwalks, just elevating these paths so people don't need to cross through the sand, and providing an easy access and an elevated access for sand accumulation to occur under the boardwalk. Our most useful technique, which is biomimicry, just a sand accumulation technique. Exclusion barriers, just to control traffic along the coast and of course along the dunes. And planting, which is also very important just to stabilize this dune. And no project is complete without monitoring. So we do use a lot of drone technology in our projects just to monitor how these restorations have been going along and just the progress. And of course, they offer a lot of information when you analyze these images through photogrammetry programs. Just converting the visual data from the drone into numerical data that lets us track the changes of these restorations along time. The mangrove restoration, the reasons for these restorations are very similar to the reasons for the dune restoration. They are, of course, habitat for many species, and some of which are critically endangered, like the yellow-shouldered blackbird. But of course, they offer protection from surge as well. And you see that there is some similarities there, which is, again, one of the main reasons why these ecosystems need to be restored and why we're working with them. Causes for this ecosystem's degradation, of course, Hurricane Maria impacted them very negatively. These are just some images of the coast of Isabela, where one of our main sites is. You can see that the before and after pictures of these sites just show the incredible devastation that they suffered. And the fact that there has not been any regeneration coming along. Another big cause of the degradation of these ecosystems is the misuse of land and illegal land appropriation. Just mangrove forests being completely shaved down and construction taking place in these areas. This is one of the most recent cases in Bahía Salinas. And of course, you could just appreciate how these ecosystems do not seem to be regenerating at all by themselves, which is why we've been taking action and just helping these ecosystems out. I would say that the main practices that need to be implemented when restoring mangroves is, of course, a propagation, because these are very wide stretches of land. And when you don't have access to these seeds and the mangrove is not regenerating, then we need to plant new plantlings in these sites, and propagation is key for this activity. Of course, planting needs to take place. Hands-on planting is, I think, one of the most important activities. Just reintroducing these plants into these ecosystems. In some cases, it is needed, and in other cases, you can just slightly take a slighter approach when planting, just if seeds are readily available. But yeah, most of our projects right now do involve a lot of planting. And of course, monitoring is also important. This is also done with drone technology, just mapping out the sites, and they let us know what parts of the wetland need to be planted sooner than later, and of course help us keep track of what we've been planting and where. And monitoring also is of species of animals. That lets us just know if the restoration has been going along well when you see that species that weren't present in the past are or have been reintroduced. So I would say that the most important part of all of our projects is the community involvement and the outreach. So these projects are basically to serve the community and to help communities out. And so when you involve the communities, they kind of have a greater sense of responsibility, and just letting them know and teaching them about what is needed and how to protect these sites. I guess this just makes the restoration go along easier, and it sets up the restoration for a longer and more productive activity along the way. So I think that is all in my part. So if any of you have any questions, please let me know.
Thank you, Roberto. I appreciate you sharing the restoration, the critical work that y'all are doing with restoration. And one of my colleagues has written a case study about the work that y'all have done with Robert, and just how critical, like you said, the community involvement and the volunteers are in doing a lot of that work, especially the plantings. So I just want to say thank you for participating today.